Hey, crazy kids. Hope you guys are doing great out there in these wild and crazy times. Not really sure what things are going to look like as we move forward, but I thought just to get things started, I would make a recording of me going through a couple of tasks from our packet every day. This is not required. But it's just something, if your parents are like, don't your teachers, aren't they giving you any work to do? Here's some work for you guys to do. You could get out your packets if you have them and, go through these with me as I go through. If you left your packets at school, that's totally fine. Also, you just write down on a piece of paper task number 2 and write down the answers as they come up. Or like I said, just, whatever. Don't do it, and then we'll figure out where we're at when we get back. That might change. It's possible that in the future we'll be able to require you guys to do some of this stuff, but right now that doesn't seem to be the case. But I just thought I would get something going for you anyway. Okay, so this is going to be really short and quick because there's nobody bugging me. I don't have to yell at Zoe to get off her phone, and Bryson's not going to interrupt 5 times to ask if he can go use the bathroom and things like that. So we'll be able to rattle off these couple of tasks pretty quickly. So task number 2, which I know you guys already did a little bit of writing on this when we were back in school, but we didn't officially answer all of the questions. The first question is, how does the value of c relate to the graph of the function? Well, first of all, we should probably talk about what the heck a, b, and c are. So let me kind of put that up here. A is the number in front of x squared, in case you don't know that already. B is the number in front of x, and c is just the number. Okay, so if I look at these guys right here, in this one, a would be 1 because this is 1x squared. B is 2. C is negative 3. In this one, A is negative 1. B is still 2, and C is negative 3. And in this one, A is 3, B is 2, and C is negative 3. I'm sure you kind of get the idea. So, the number in front of the x squared is A. The number in front of just the plain old x is B. And then the number that's all by itself is C. Why do these matter? Who cares? What's the point anyway? Well, each one of these numbers affects the graph in a different way. How does the value of C, for example, relate to the graph of the function? The answer to that is that C is the y-intercept of the graph. So for this guy right here, the y-intercept is negative 3. This is negative 3, negative 3, negative 3. This one's plus 3, plus 3. This one would cross the x-axis at 4, or the y-axis, sorry, at 4. And this one would cross the y-axis at 5. Okay, so that's our first exciting learning of the day. How about if you can tell, how will you tell if the graph opens up or down? Well, that relates to the a value in the function. If a is positive, the graph opens up. If a is negative, the graph opens down. It's that simple. So again, to go back and look at these examples right here, A right here is positive, so that means the graph opens up, so it'd be a guy that looks like that. This one right there, though, is negative, so that means the parabola is going to open down. This one is positive, so the parabola opens up. Okay? All right, and then the final question about these things are, what determines the width of the parabola? Well, you might think to yourself, C is the y-intercept, A is whether it opens up or down, so B determines the width. Sadly, if you thought that, you would be wrong, because B does something weird and funky and complicated to the graph that we're going to talk about later. What determines the width of the parabola is how big A is. You can think of A as sort of being like the slope of the graph. So the bigger A is, that means the steeper or narrower, how do you spell narrow? Narrower the graph. And if A is smaller, then that means that the graph is actually wider. So like I said, you can think about that as being the slope of the graph a little bit. So if I did something like 5x squared, so A is 5, so we know that the graph is opening up, and since that's a 5, that means I would start here in the middle and then go like at 5 and over 1, and so that means that the graph of the parabola would be pretty skinny. Whereas if I did something like 1/2 x squared, this parabola is still going to open up, but you can sort of think of the slope as being 1/2. So if I start here, I would go up 1 and over 2, and then that means the graph would be quite a bit wider. It's not really the slope of the graph, because if I go up 5 over 1, then the next point is not up 5 over 1. But at least it gets you started, okay? So those are the answers to task number 2, which is, I think, where we left off. So these we were supposed to figure out what A is and B is and C is, and then look at the graph, and I'd call on people and say, hey, what's A, and what's B, and what's C, and what's the y-intercept, and is it going to be narrow or is it going to be wide, and is it going to be opening up or is it going to be opening down? Austin, pay attention. Zoe, put your phone away. No, Ashlyn, you can't go talk to Heather. That kind of thing. But we don't get to play those games for right now. Maybe at some point in the future. Okay. Yeah, so let's just jump ahead to task number 3. Task number 3 relates more directly to what we were doing the last time we were together in school, which was to talk about how parabolas relate to things that fly through the air, like gravity. And we talked about there being 3 different numbers, the -16, the 5, and the 15. So I don't know if you remember this, probably you don't, but the -16 comes from gravity. The 5 comes from the initial velocity of whatever is flying through the air, and the 15 comes from the height that the object started at. Okay, so in this equation here, which we're going to talk about quite a bit, we have already, that is for projectile motion. So that's if you throw a ball or something, or launch a rocket or something through the air. That's an equation that you can use to track its path. The -16 is from gravity, because gravity is pulling things down. The 5 means that the initial velocity is 5 feet per second, and the 15 means that they were the object was thrown at a height of 15 feet. So who can change and who can't? You can change the 5 and the 15. For example, you could throw the object harder, and that would make the 5 be a larger number. Or you could throw it less hard, and that would make the 5 be a smaller number. You can also change the 15 by throwing it from a different place, like from a 2nd-story window or a 5th-story window, or just from the ground. You cannot change the -16, because that, my fine young friends, is gravity, and you can't change gravity. Okay. Okay, consider what would happen to the height of the graph if of the object if you did change the values that are free to change. Would it have a different starting point? So let's call this value right here, to be consistent with what we were talking about before. This one is B, and this one is C. Okay, so if you change C, you can or you will change the starting height. You would also change the maximum height, because if you start from a higher point, the ball's going to go higher. If you start higher in the air, that is if you leave the other things around the same. Would it be in the air for a longer or shorter time? So you would change amount of time in the air. If you threw it from a lower point or from a higher point, if you throw it from like the Empire State Building, then obviously it's going to be in the air for a lot longer than if you threw it just from the ground. Okay, and it wants us to sketch 3 examples. Not doing that. All right, what about if you change b, which is the initial velocity? If you change b, you don't change the starting height. That stays the same if you leave c alone. But you would change the maximum height, because if you throw it harder, it's going to go higher. Or if you throw it not as hard, then it won't go as high. And then you would definitely also change the amount of time that the ball or whatever is, change the amount of time in the air. You would change the amount of time that the ball is in the air, because if you throw it harder, it's going to go higher, and if it goes higher, it's going to be in the air for longer. If you throw it softer, then the opposite's going to be true. All right? Okay, so that's all I got for you today. Like I said, I don't know, man. I'm just checking in. We don't know what's going on quite yet, what this is going to look like. So I'm just going to go ahead and get started with this. I would encourage you to check your student email fairly regularly. Get on Google Classroom fairly regularly, or just turn on notifications or whatever, so that you can be up to date on whatever happens next. But right now, we're not requiring anything from you. I just wanted to get something going. All right, hope you guys are taking care of yourselves, and hopefully I'll have the chance to yell at you again in class before too long. See ya.